Welcome back, everybody. This next lecture is for DHCP snooping. I'm not going to bore you to death. You're going to have a presentation to look at. After you look at the presentation, look at the lab, pay attention to it. But this is what I want you to realize, as you're going through this, especially the lab, why in the world, and I copied the lab directly. I mimicked it, meaning I looked at the book and I created the lab and the packet tracer. Why is your real DHCP server that's assigning IP addresses for your internal network across a wide area network? And that's exactly what I have, okay? But whatever. All right, so take a look at the presentation, all right? New terminology. So pay attention to that. I've highlighted some stuff. And then after the presentation, we'll come to the lab. So sit back, relax, pause, rewind, learn it all. I'll see you inside. All righty, welcome back, everybody. Now that we know the different ways that we can configure DHCP or the different devices that we can configure DHCP on, let's talk about something called DHCP snooping, okay? Now, like it says there, DHCP snooping, what it does, it acts like a firewall or an ACL because it's looking at that DORA process, okay? It's looking at that DORA process. So it's making sure that, hey, is this legitimate traffic? Is this okay? So it's looking at it. If it's good, if it, where you'll see here is based, I see on the lower bullet, the last bullet, is based on trusted and untrusted ports, okay? And this operates at layer 2, right? Layer 2 of the OSI. So commonly, we use layer 2 switches. You could use layer 3 switches. People there, they use layer 3 switches here because they're boycotting routers for some reason, and they want to use monstrous switches, and that's going to be what they're going to use to route too, because that's just the way it is. All right. So, but there's rules to that, and we'll get to it at the end of the presentation. But it does operate at layer 2, and more than not, it will be on layer 2 switches where you're configuring this. Now, its main purpose is to prevent, and I use the common word, rogue. You all know what that means, right? DHCP servers. And by default, DHCP snooping will work on all ports, all right? You can put them in trusted or untrusted. By default, everything is trusted, all right? So you got to deliberately go in there and untrust something, okay? And then DHCP messages that are, you got to trust, you got to explicitly tell it, hey, this is a trusted port. And then other ports will be untrusted. All right, DHCP messages that are untrusted. This is somewhat of the process, right? Because when it's going through the DORA, right? So if you're getting a DHCP message that's coming from the server and it's coming through an untrusted port, it's going to discard that completely. It's just going to kill it, okay? If it's coming from a client, the DHCP message through the untrusted port, at this point, this is a client. So let's filter. Let's take a look and see if we have it on our MAC address list, our CAM list. All right, if this is one of the legitimate MAC addresses. So it takes a little, it looks at it a little bit more carefully because it's a client. It's not the DHCP server. And if it's a trusted port, obviously it just lets it go through. Not a big deal. Nothing happens. Okay. But when it's untrusted, as you can see, it's not going to allow any DHCP servers to give you anything. And the clients will just be filtered. We'll just make sure that, hey, they're cool. This is legitimate traffic. We're going to allow this, okay? All right. So I told you this is an actual word in this section. DHCP, I try to pronounce it. I've been on Google a million times pronouncing this thing, but I don't know if I get it right or not. Spurious, Spartatius, Spartan, I don't know, spurious server, okay? Well, this means it's fake, false, phony, not real, rogue. Why don't they just say that, okay? So they just, like I said in my YouTube video, they're improving our vocabulary, all right? But anyway, the purpose of the DHCP snooping. So what happens? The piece sends that discovers, it's a broadcast, right? So the spurious, I'm going to start calling it Spartan, I swear. The spurious server replies to the PC DHCP offer. right? Well, replies with PC with a DHCP offer. So it's replying to that discover with an offer. But that's the fake guy, the false, the rogue server, because it's in between. Say, truth. I'm going to get that DHCP discover, and I'm going to send you legitimate traffic, a legitimate IP address, a legitimate subnet mask, legitimate DNS server. But I'm going to be your gateway. So everything comes through me. Why? So I can do a man-in-the-middle attack later on. All right, that's the whole point. So you're going through this device that has the software, more likely, okay, of DHCP server installed, so it can, hand out legitimate IP addresses on the network, and everybody goes through you though. All right, and then you come later on, you got all their info where they're going to, you have software in there that records, all their keystrokes, all these things. Man-in-the-middle attack. All right, but, and this is what I find funny, DHCP clients can use DHCP release. We all know about ipconfig release renew, right? This is where we're forcing the DHCP server to give us an IP address. This is when we use it. There is also something, and it's highlighted for a reason. All right, DHCP decline. For me, in my experience, in my humble experience, I've only seen, where people get, if they don't get an IP address, they get an PIPA. So they're not part of the network and they can participate. But apparently, clients have the capability during the DORA process to send a DHCP decline if they see that in the assignment, or the lease, I should say, that's being sent out, right, in that offer, it's your IP address. You already have that IP address. So it's like a gratuitous ARP that's going on. Sounds familiar? And then the DHCP says, hi, I decline you. I will not put you. I do not accept it. Go away. All right. So that goes on. That's a new terminology. DHCP client, I think. I haven't seen that in any books, Microsoft or otherwise. Cisco, Microsoft, Cisco or CompTIA. I've never seen a DHCP decline, okay, ever. Okay, I've never seen that. All right, but hey, this is something that we need to understand now, that during the process of DORA, the client can actually decline the offer if it notices that it has the same IP address he has. Isn't he looking for an IP address? Well, anyway, he sends a gratuitous ARP, okay? And that's what happens, all right? So that's the purpose of us configuring DHCP snooping. So globally, you would say IP DHCP snooping, and then you would choose the VLAN. I just made that VLAN up. Whatever VLAN you're using, you could put IP DHCP snooping VLAN 20. And as the book says, these are required commands. One will enable it, and the other one will tell you it's on this VLAN. All right, perfect. So you can, it works on all ports. So, whatever VLANs you're using, however you have designed your network, they're good to go. Because, what they say is, normally it's internal. It's internal because as you'll see after this presentation in the lab, that they have the real DHCP server, because I followed the book in the lab. They have the real DHCP server that's supposed to assign somebody in an actual LAN across the WAN. So I have a frame relay lab, right? I have a frame relay connection between two different routers. And so they have to cross the WAN. Well, you've learned in the previous lecture that if that's the case, you need a relay agent. Well, I use the IP helper address. Okay, it's same crap. All right, so yeah. So I don't know who would do that. I worked for a company that did that. They actually did that. It was a career college. I'm not going to go any further than that. It was a career college, and when they first started out, their headquarters company, everybody was logging into the domain controller, whatever county they were in. They had to log into the headquarters company in that particular county. And their DHCP server was there too. If they were down, then all the campuses were down. How about that one? They learned quickly. that was not a good idea. Because in the book it says, normally people, they're in your network, they're doing this stuff on purpose, right? So don't allow people to bring in friggin' their devices, or if they do, you better look at their devices with 20 eyes and put software in there that will prevent them from doing anything they shouldn't be doing. Okay, to watch them. Can't trust anybody these days. All right. So anyway, those IP DHCP snooping, you enable it. IP ADC snooping, this particular VLAN. Okay, those are required commands. And the next command, you have to do it. It's you have to trust a port. Hey, I trust this port. This is where the DHCP server's at. So I trust this port. Okay. And then option 82. Option 82 in the book, they disable it. All right. And they just give you, let's say, hey, as you can notice in the highlighted section, we have option 82 that is disabled because we don't want more information. All right. Because apparently, if you're using, and a lot of you, and some are very passionate, some people that are out there on the social media news, okay, of IT, they want to shoot people and stuff, okay? They're using spanning tree, and if you're using a router, how dare you? Yeah, okay, chill. If you're using a layer 3 switch, okay, which you better, or somebody's going to come and just, chop your head off, you're using it with DHCP relay agent, you should enable that because apparently, DHCP adds additional information. And as it says there, you're going to go into allowing DHCP servers to select sub-ranges in the pool, right? Obviously, that's what the point is of a relay agent, a helper address, right? You're getting from somewhere else. Because in my lab, I have 2 scopes, okay? But I disable, option 82. I don't care. All right, this is just a lab so you can understand the concepts of it. But this is, when you should use it is when you're using layer 3 switches and you're using DHCP relay agents so they can give you additional information on the subcommands that they're getting to give you more info. But the default on layer 2 switches is disabled. If you want to type it again and say, IP DHCP information and option 82 disable. Okay. No worries. Or you're going to enable it. That's up to you. All right. Not a big deal. All right. But, they will want you, if it's layer 2, to disable that. If it's layer 3, you want to enable that. All right. But it's completely up to you. But that's what DHCP snooping is. All right. And it's just a preventative measure of security, another layer of security that we would use, all right, to make sure that we're getting legitimate IP addresses. Okay. IP addresses. But again, when you're reading your book, even if you have it here, when you're reading your book, please go through a fine-tooth comb. And if you go on YouTube, you're going to see a little silly skit. It was silly. I just did it on the fly. I didn't even prepare for it. Oops. I didn't even prepare for it. This right here, that word, that just threw me for a loop. I had to go look it up. I had to go look it up and see what it was. But now remember, they're giving you new terminology, all right? New terminology that you need to understand, all right? And more importantly, like I told you in the previous lecture on DHCP, you better understand that DORA, discover, offer, request, and acknowledge, where these messages are coming from, okay? And who's sending what. Because we got this DHCP release and DHCP decline, which is highlighted. Okay, you need to know that. And then obviously the commands. Will you configure this? I doubt it. If you do, it's not a big deal. It really isn't. And you're going to see now the the lab that I have that comes with this, which is funny. And these are some additional commands, which, Packet Tracer doesn't support these, by the way, as far as the ER disable recovery commands. Packet Tracer doesn't support them. Okay, it'll do the rate limit. It'll do that. Okay, and the default is 100 packets per second. That is what is recommended. All right, in the book it puts 30, but it's and then when you look at it, right, when you show IP DHCP snooping, you see that, and you just see PPS. It's packets per second. Okay, that's what packets per PPS is, packets per second. So the recommended for untrusted rate limit is 100. No more than that. okay? And then, you know, here we see these commands again, all right? Because we want to take our ports out of ERR disable state, okay? So we want to do it automatically, either by saying, hey, he reached the DHCP rate limit, so like, let's put it up again, okay? Let's not leave it in shutdown state. Okay, that's a problem. All right, and then the other one is a recovery interval, which is in seconds. All right, anywhere between 300 and 400, you want it to come back. So, I mean, I can understand, you know, because the administrators has to do more work, right? So we don't want to do more work. We don't want to do our due diligence. We just want things to happen automatically, magically, you know, like the unicorn. No, okay? I am totally against these two commands, okay? I don't care if you work for friggin', I don't know, you know, the largest company in the friggin' world, all right? Because not everybody, when somebody states, I have done everything and anything and I've worked everywhere and all the, then my man or my girl, okay, my woman, all right? If you worked everywhere, what's going on? Company doesn't like you, or you just decided, well, I'm just going to hop around jobs every 2 to 3 years, okay? And if you have 20 years experience in order to work everywhere, that's like a what? If you work 1 year at a company, that's what, 20 different companies? That's not that's not a lot. It's not a lot, all right? So, I mean, we have more than 20 browsers, all right? So, you know, people are just silly. They think that, you know, they've done it all and configured it all, which is an impossibility. Without facts, they can give things like, hey, this is the way it should be. No. So what I'm telling you now is DHCP snooping, all it is, it's a layer 2 thing, all right, which you can configure in layer 3 switches as well, all right, to go ahead and trust or untrust ports. So you can minimize the amount of illegitimate traffic, all right? And I, Lazaro J. Diaz, or Laz, will not ever use ERR disable recovery automatically so it can come back to an up state. Yeah, no, that's not going to happen, okay? Not going to happen. I'm going to have to do it manually. I don't care, because if it's my network, yeah, my eyes are going to be glued to that, or the person who's working with me, their eyes better be glued to that, all right, to the dashboards, whatever we're using, whether it be the Cisco DNA, SolarWinds, whatever, okay? You better be paying attention to all these alarms and bells and whistles, because I know when I worked in telecommunications, that's what I did, okay? We made sure that we looked at it, you know, we were looking at this particular dashboard, and anything was red, we drilled down into it and found out what the hell was going on. Then created tickets and so on. But anyway, so this is the end of the presentation. Now you're going to see the lab. Pay attention to it, okay? Because like I told you, the rogue DHCP server is already in the network, okay? And then the actual DHCP server that's supposed to be assigning you an IP address is outside the WAN. And why did I do that? Because in the book, the Cisco book, they actually put a cloud. I don't know what they're teaching now, but I know in my teachings, when I was going to school and throughout all these years, a cloud meant WAN. Okay? So, all right, whatever. So that's what they're doing. So pay attention to the lab, look at the commands. I go back and forth quite a bit so you can tell which is which. All right, so just pause, rewind, you know, look at it, and then you try yourself. Cool? All right, I'll see everybody in the lab. All right, here we go, everybody. This is the lab for DHCP snooping. We already did DHCP. That was pretty simple. We have 4 examples. This is how you can prevent, as I stated in the presentation, attacks from having rogue servers or rogue DHCP servers on your network, preventing things from happening. Now, this is pretty exact. I don't want to say exact, but pretty similar, the same that you will see in your Cisco Pressbook. You have PC1, the spurious, or the fake rogue DHCP server. And then you have, it's connected to the same network that you are in. You're in this network. They have a cloud in the book. They have a freaking cloud. A cloud is a wide area network. So I did frame relay here. Okay, this is going across a frame relay network. You can see this is a different network, 1.1.1.1.0. That should give you a clue already about what things are going to happen. And here's another network. So you have a network here. You have one broadcast domain here. This is another one, all right? Totally different network. And then here's another one, all right? So the scope here, let's take a look at it. Let's open this up so you can look at it nice. All right, so here you got the default. I left the default server pool. I didn't want to create a new one. This is a server pool. Default gateway 10.1.1.4. DNS server 10.1.1.2. The starting IP address is 10.1.1.100. And then 255.250. Boom, 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 boom. Right? Cool. The service is on. All right. Here we have a DHCP server as well. Okay. But here I decided to make the real deal Bubba scope is I'm sorry. Oh, see, I need to make a change here because so this can go on top. Well, no, real deal Bubba is on top. 10.1.1.4. Okay. That's the scope for that particular network. That's the correct default gateway because it's statically assigned. All right. The DNS servers is 20, where the other one is 2. This one says it starts at 100. I'm going to make it, well, no, I want it at 100. 100, yeah, leave it at 100. 255. Okay, so this is 100. This guy starts at 100. All right, and this guy, I believe, started at 50, if I'm not mistaken. Where did he start at? Oh, no, he started at 100. Let's start him at 50. Okay, let's do it that way. Let's save that. So he's going to start it at 50. Everything else the same. He's got a 2 for a DNS server, while this one's a 20. And let's verify that again, just to make sure that that's what it is. So we start at 50 over here, and we have a 20 for the DNS server. And here, okay, what's going on? 100. All right, let's save that. If that changed over there again, that shows an issue with the packet tracer already. And now let's stay. Okay, so this one starts at 50. The other one, let's save 50. That's 50, 50, 50, 50. DNS server is 2, right? 2. Okay, so we're cool there. I'm not going to close it. And then this one is 100, 100, and DNS server is 2. All right, cool. So everything is green. We should have connectivity. This is the 10.1.1.2. If you look at the IP address, let's go to the desktop. Oh, 10.1.1.1, I'm sorry. 10.1.1.1. So let's say we have connectivity first of all, before we start doing anything. So we're going to ping 10.1.1.1. And we have connectivity. So we have connectivity across the network. So this one you can see is received an IP address. Let's get rid of it. Let's renew it. Let's see what it gets. So I got 10.1.1.2, and it's got a subnet mask of 255.255.0. Now, it should have gotten starting at 50, okay? But you can see the DNS server is 10.1.1.2, which is what this server here services, the DHCP. The DNS server is 10.1.1.2. I don't know why that went back to 0. Oops. I don't know why that went back to 0. I had set it higher, but whatever. Okay, so here's the start IP. Is there a start IP address? No, it's 0. Okay, the start IP address left at 0, so it assigned an IP address of 2, 10.1.1.2. But the key here is there's the 10.1.1.2. Okay, the 10.1.1.2 is this guy, 10.1.1.2. That is our rogue, phony, fake DHCP server in our LAN. This is not my example. This is the example in the book. All right, this is the real DHCP server, okay, which the DNS server is 2 as well. Okay, so let's put that as 30. How about that? Okay, let's save that. Save. Did anything change over here? No, right? Let's release renew. And you can do ipconfig / release ipconfig / renew to force it. All right, we just packet tracer just back and forth. Still getting a 2, not a 30. All right, and we're going to verify that this indeed. You got to do a lot of checking in the packet tracer because this thing's just crazy. Okay, we still got 30, so it didn't get that. All right, so we're saying, hey, listen, we're getting that gratuitous ARP message, meaning it's going to send DHCP declines. Hey, you're sending me an IP address. We don't have DHCP snooping on right now, so we're finding out we're getting the wrong thing. Okay, we're not supposed to be in that network. Okay, so first of all, what you need to look at if you're in this type of scenario is that they're not going to get anything from this guy unless you have an IP helper address here telling this guy, hey, listen, dude, the IP address, the scope that you need to get it from, here's your DHCP server, right? We just saw DHCP. If you're going across a broadcast domain, right, because he's in the same network, and this is straight from the book, page 152, okay? Not page 152, I'm sorry. Let me see here, page 148. 148, that's the friggin' thing right there, okay? You can look at it. It's the exact same thing. Why do you have the fake DHCP server within your LAN? All right, no problem. That's why you're bringing BYOD inside your network, but okay. All right, so we're thinking, oh, okay, well, we just did DHCP server. If you want to get an IP address from this scope, you need to tell this guy right here, this router, this interface, hey, listen, IP helper address, the server I want my IP address from is from the 172.16.1.1. All right, so I'm going to go in here. And this is interface F00, okay? Enable conf t IP, no, I'm sorry, interface F0/0 IP helper address 172.16.1.1. That is my, let's take a look that it took effect. She'll start. There it is right there. So it's pointing to that DHCP server, right? Okay, so we're going to go ahead and we're going to release renew again, right? And basically just do this and see what happens. Still getting it from this guy because there's no DHCP snooping going on, right? So let's enable DHCP snooping on this particular, on the switch. Okay, so as they tell us, we got to do two things. Config T. We have to actually tell it IP DHCP snooping. Turn that on and do IP DHCP snooping for VLAN 1. Okay? But we have to have a trusted port, which is this guy right here, F024. Okay? So if this is trusted, everybody else is untrusted. So we go IP interface F, oops, that says it. Interface F0/24. We're going to do IP DHCP snooping trusted. We can put a limit on there, but we're just going to put trust, unlimited, right? Trust. You can trust that port. Do WR. Okay. Let's see what happens. Well, let's take a look at the show command real quick. And let's see what's going on. Control Z. Show IP DHCP snooping. And you can say F024, yes. F01, no. F020, no. Okay, who's F01? Is this guy. F020 is this guy. He's trusted. Okay, so let's go ahead. Come over here. Let's do this. And let's do this and see what happens. Ah, look, 10.1.1.100. Now the DHCP server, the DNS server is 10.1.120. Where the hell I got that IP address? I like to know when I put 30. DNS server is 30, not 20. But wait a minute. Yeah, it's 30. I don't know why I did that. Let's do a fast forward through time here. Da-da-da, da-da-da-da-da. Okay. And let's do it again. Okay, I got a 101. It's still getting a DNS server as 10.1.1.20. I know what we can do. Let's see if we can do an ARP -A. I'm just clearing cache here. There are no cache entries. Okay, cool. Never mind that. Let's do an actual release renewal. How about that? Let's do an IP config. If I can type ipconfig /release and then renew. Let's see. I'm still getting 10.1.20. This is not 20. This is 2. No, DHCP, sorry. Oh, look, DNS server 2. Starting IP address is 0 over here. So over here, DHCP is the pool. Oh, goes, look, the real deal came down here. It is 20. It was 20. See that? It changed to 20. The real deal. Why did that change? Oh, okay. So let's put, okay. Oh, goes, look, I changed this one to 30. That's why it came to the top. All right. So let's put 60 over here. There's the kind of things you got to do with, so I can play with it. See, that's on top. Real deal Bubba is on top. Okay. So let's do this again. There we go. 10.100. There's the 10.1.160. That means it's getting an IP from here, the 60 DNS, right? Because this is a 2 DNS. Okay. Even though the network here is 10.1.1.0, okay, here, or I want to say the start IP address. The start IP address is 10.1.1.0, okay. Here, the start IP address was 10.1.1.60. So it actually gave me something from that pool, okay. It gave me at 100 actually. And the DNS server, I changed the DNS server to 60, okay, whatever. So the DNS server is 60. Okay, so now I am getting an IP address from the real DHCP server instead of the fake DHCP server because we went ahead and turned on, oops, too big. Okay, we actually turned on show IP DHCP snooping. We turned on for VLANs 1, we didn't do this particular option that we talked about earlier. Okay, that's fine. But you can see that port 24 is a trusted port. All other ports are not trusted, but I didn't put any limits on it. Okay, so it is going to, not filter, but look at these frames coming from this DHCP server and say, nah, we're not going to take it. Okay, so, but this port will. So that's where you're going to get assigned an IP address from this particular DHCP. But at the same time, okay, we turned on, you saw before we turned it on, even if you put the IP helper address in there, which you're going to have to because it's not just going to happen magically, okay? We saw we were getting it from here, all right? Even if you have put the IP helper address, we have to turn on DHCP snooping. We have to, all right? And this is the basics of DHCP snooping. There's a lot more things you can do, but for the CCNA certification, that's more than good enough. You can always add the element for layer 3 switches. When we do it there, you can put DHCP snooping and add that option that we see here for option 82 on the untrusted ports, okay, to give you that information. But the point is, take a look at this lab. Analyze this just for a second. First of all, why in the hell is the real DHCP server outside the local area network? Or is this acting as your provider? That's not, nothing is said like that in the book. It's talking about the DORA, discover, offer, request, and acknowledge, right? So no, you have to make sure it's going to be in your LAN. If anything, somebody may sneak in a DHCP server in your LAN And there you would put, this is the only trusted port for that, or, a range of ports or what have you that you're trusting. Others won't be trusted, okay? But definitely you got to be very careful, so it will look, okay, at those things. And the rules, the logic of DHCP snooping is going to say, I'll try to keep that consistency of the MAC addresses when it gets the request, all right, and it will discard, right? That's where I made fun where the DHCP, what did I say? DHCP decline messages, DHCP release, DHCP decline, all right? So it'll decline the messages from the DHCP server because this is not a trusted port. So it's not going to get anything from this guy. I know I should have made something completely different to make it easier on you, but you can just see it in the DNS address. It's not 2, okay? Where this is actually the DNS server is 2, okay? So you're not getting it from there, you're getting it from here. But again, why in the world would you have your DHCP server to assign you an IP address to your LAN for your own business across a wide area network? Okay, that just doesn't make any sense. 1. 2, you need to have the IP helper address here in order to tell the offer that's coming this way, hey, let me take you where you need to go. Let me go across this frame relay, because that's exactly what this is, and then take you over here. All right. So if you look at something like this, because that's how the way they have it drawn in page 148 of the volume 2 CCNA 200-301 book, that's how they have it drawn. They leave a lot to, for you to say, okay, it's going across a wide area network though. That's what the cloud represents. Okay, it's going across a cloud wide area network. So why are you trying to get an IP address from a wide area network? Now, if you're telling me this is an ISP and it's assigning you an IP address, okay, I understand that, but nowhere does it say that this is, an ISP that's giving you an IP address. You just assume that that's what it is. To me, I look at it as, why am I assigning an IP address to myself? I mean, come on. I mean, I can see people going into companies and bringing in DHCP, bringing in software that's DHCP software, or their own laptops that they can run DHCP on, and then they have a rogue DHCP server. And hell, when I was in the career colleges, I set up DHCP servers. The school wasn't VLAN'd out because they just don't listen. And I was assigning IP addresses to everybody because if they didn't even take the time to put in VLANs, they didn't even take the time to do DHCP snooping. Okay, even using some sort of third-party software, they just came and told you, hey, Laz, you're sending IP addresses to everybody else. Oh, okay, let me unplug the switch from the wall. All right, so I don't mess anybody around. So yeah, that's the reality of it. All right, but just know that this is the example in the book. And all it is just turning on DHCP. You saw the command. All right, it's just turning on IP DHCP snooping for the VLAN you want the snooping on and the port that you're going to trust. And then that's it. You option 82 is something different, but that's it. That's pretty much it. And then just take a look at your show IP DHCP snooping, and you see who's who and what's what. And make sure you're getting the correct IP address. So don't do like I did. I did like a very sneaky, I did the same pretty much IP addressing, trying to mimic the same thing that's going on the other side. But I made the DNS server different, so you can see this coming from a different DHCP server, But that's it. That's all there's to it. That's all there's to DHCP, and that's all there is to understand. Okay? So if you understand the DORA, which I told you last, when you saw the lecture on DHCP, that's the process you need to understand, because that's the logic that snooping looks at. All right, and it does create a table. Okay, it does list and create a table of particular MAC addresses. Okay, that are coming through, so to know what's legit and what's not legit. And again, you put trusted and untrusted ports on there, so you know what's going on. All right, there's your DHCP snooping lab. Pretty simple. I'll see you guys in the next one.